Okay, so the slide that we left off, we were talking about the role of ribosomal RNA and how and basically ribosomal RNA composes the ribosome. It makes up the ribosome, and it's produced from a DNA template in the nucleolus. I don't know if you remember this, but in the chapter, it was chapter 4. In chapter 4, when we learned about the cell organelles, we learned that the nucleolus, which is inside of the nucleus, makes ribosomes. Well, now you know how that happens. A DNA template is used to code for the ribosomal RNA that composes the ribosomes. Okay, so a completed ribosome has 3 binding sites. It has an E site for exit, a P site, which means peptide, and an A site, which means amino acid. So when the transfer RNA comes in and adds the amino acid, it does so at the A site. Then that amino acid is moved to the P site, and it becomes part of the growing peptide. And then the E site is for when the transfer RNA exits the ribosome. So a picture helps a lot to understand that. So, all right, here we have one particular ribosome, and we can see that ribosome has 3 binding sites, 1, 2, 3. This is the A site, the P site, and the E site. And you can also see that each ribosome is composed of a large subunit and a small subunit. Both of these are made of ribosomal RNA. And here's a bigger look at it. Here's your A site, your P site, and your E site. So here's your messenger RNA, which is attached in between. It's kind of sandwiched in between the large and the small ribosomal subunit. And what you see down here is you see this long chain of, it looks like a string of pearls, blue pearls. It's this long chain of amino acids, which is our growing peptide or polypeptide. So what happens is, as a new amino acid is brought in, it comes in at the A site. I know the A stands for amino acid, but I always think of it as added. That is where the amino acid is added to the ribosome. And so we have the A site is where the amino acid comes in, and then you can see in the next stage that the transfer RNA moves over into the P site. That is when the amino acid is permanently attached to the peptide. Sometimes I think of the P site as permanent. And then in the next stage, the transfer RNA exits. It scoots over here. It leaves the amino acid that it brought in. It already attached it to the polypeptide. So now the transfer RNA can remove itself from the amino acid, and then it can exit the ribosome. So that's how it works. There's still stages of translation. There's initiation. The initiator transfer RNA always has an anticodon that is complementary to the codon, to the start codon. So the start codon is AUG. Then always the initiator tRNA anticodon is UAC. And it always carries the amino acid methionine. All right, and here you can see the initiation process. You see the transfer RNA with its anticodon UAC binding to the codon AUG, and AUG is the start codon that codes for methionine. MET stands for methionine. So that's the initiation process. Then you have the elongation, which is the growth in length of the polypeptide. That occurs as transfer RNA adds more transfer RNAs come in and add amino acids to the polypeptide. And translocation is when the second transfer RNA moves to the P site. That's called translocation because the first RNA has to move over into the E site. And then the elongation process is when more amino acids are added. Amino acids come in and they're added to the polypeptide. And you can go back through these stages yourself. You can also watch the video animation, the tutorial video that's found in the section on translation in your eText. Now, the termination part is when the ribosome reads a stop codon. It's either going to be UAA, UAG, or UGA. These are listed on the codon chart. When the ribosome reads the stop codon, then the translation ends and the polypeptide is completed. Now, this is a summary of gene expression, which is what we call transcription and translation. It shows DNA in the nucleus serves as a template to make messenger RNA. Step 2, messenger RNA is processed. Remember, there's a cap and a tail added to the messenger RNA, and then the introns are spliced out, the introns are cut out, the exons are spliced together. Messenger RNA leaves the nucleus and finds a ribosome. And step 4, transfer RNAs with anticodons come in and match up with their complementary codons on the messenger RNA, and they transfer amino acids to the ribosome. Step 5 is showing you the initiation process where the start codon matches up with the complementary anticodon, and that first amino acid is always methionine. Step 6 is the elongation of the polypeptide, and step 7 says the ribosome attaches to the rough ER, rough endoplasmic reticulum. Polypeptide enters the lumen of the rough ER where it folds and is modified. And then number 8, during termination, a ribosome reaches a stop codon and messenger RNA and the ribosomal subunits disband. And so it's over. And then you have a summary of gene expression, and that is the end of our lecture on Chapter 12.